Hello everyone and welcome back to the Jamsey Online YouTube channel. Today we're wrapping up the final machine work and assembly on the short block of the 172 cubic inch Ford that we showed removing the sleeves from a couple weeks back. In the previous video, we were waiting on the new pistons to come in, but we had rough bored and honed the block for the 20 thousandths oversized pistons. Typically you'll find that aftermarket pistons are sized with the clearance built into the piston, meaning a 20 thousandths oversized piston that needs 1,000th clearance would actually only measure about 19 thousandths above the standard bore size. This allows the bore to be finished to the exact nominal oversize. In this case, the pistons actually measured closer to the nominal size, and in fact were even close to 1,000th above. So I did have to do some additional rough honing before switching over to a finished stone for a few strokes for our finished cylinder. I'll also note that we did increase the stroke rate on the machine for today's honing, which gives us a bit steeper crosshatch angle than we originally had. While the cleaning guy inspects our work, I'll just give you a quick reminder to comment your questions, hit that like button, and be sure to subscribe, as only about 25% of our viewers are currently subbed.
Rob, you want to go this way?
How is it?
I thought it looked good.
With our cylinders finished for the proper piston to wall clearance and good and round and straight from top to bottom, the machine work on the block is finished and it can go in for the final wash. Now on this next part, I had prior obligations, but the cleaning guy insisted on working late, so I convinced the cook to film, but unfortunately, I didn't specify on camera orientation, so this next section of video is vertical. I know it's not ideal, but I do encourage you to stick around as it is some good information.
I'm going to try to take care of the connecting rods on this. As you recall, when we started working on those the other day, we realized that one of the rods had quite a bend in it here. Evidently, there was some liquid in the cylinder it tried to compress, and that does not work so well. So we got a hold of the customer, told them about this, and they hopped on eBay and found us another good used connecting rod that matches the others. I already checked that on the scale, and actually this rod is closer in weight to matching the others than this one that is bent. So he lucked out there in another way. They're all within about 4 grams of each other, which is well within spec for a low RPM engine like this. But what does concern me is if you can see the color on this rod, it is darkened. It has been hot at some point in time, as well as the one that was bent here also looks dark. You can kind of see in the bean here, it's a little bit discolored. Generally, when a bearing has been starved a little bit for oil and it has gotten hot, even if it doesn't spin the bearing, it will actually shrink the big end of the connecting rod and cause you problems in the future if you just try to put it back together that way. So I'm going to torque caps on all these rods, and we're going to check them on the pin hone here and make sure the size is correct. I suspect these are going to be okay, but I want to just check them out and make sure. Our specs from the Automotive Engine Rebuilders Association tells me what the big end of this rod is supposed to measure, 2.423 to 2.4238. There are my 423. And let's see what this rod looks like on there. It's got a little bit of a tight spot in there. I think I have enough material there I can touch that with the hone, clean that up and have it look good. Really not taking much material off. My spec gave me from 4.230 to 238, and with where I'm at right there, I'm at 237. So we'll call that good. Okay, so we're ready now to install the new pin bushings in these rods. I just wanted to maybe show you here, bushing that we're getting ready to replace. The spec calls for 2 to 8 ten-thousandths of an inch clearance between this pin and the bushing. And we obviously have more than that because I can actually wiggle that in there. Just put this in perspective, an average human hair is about 3/1000ths of an inch, which is 10 times larger than the low side than the tight side of spec here. So just imagine this has to be fit 10 times closer than what it would be if you just slipped even as much as a human hair in there. Now, Sonnen, when they designed this machine and this gauge, they made it what I call to be idiot proof. You don't have to be smart to use it. You don't even have to be able to read a micrometer, because if we take these larger centering fingers off here, always put those away so we don't lose them, and you get out the parallels. It's a parallel fixture, and you take 2 wrist pins from your set of pistons, put those in there between the parallels, snug it up, back it off just a teeny tiny bit there, and then you adjust the gauge, set that on 0. And now, without even having to use a micrometer, I can check my pin bushing to figure out if I have 2 to 8 10,000ths clearance, I think is what the spec was. This 2 here is 2/1000ths of an inch. I should actually be just 2 of those tiny marks, 2 to 8 of those marks away if this was a good bushing. It is so worn, it won't even hardly read on the scale here. So, but we knew that already just by the feel of it. So anyway, I'm going to go ahead and take these bushings out, and we'll press in the new ones and show you how we fit those. Generally, with these thin wall bushings, I can just take a air chisel like this, get under the edge of it, and I should be able to just push that right out of there. As you can see, where I went through, no damage. There is a mark in here from the last guy. Somebody tried to saw those out of there, put a cut in there. I don't like that, but that's what we have to work with. That's actually our replacement rod. It does have a little groove cut in there. I'm going to say somebody used a little saw and they tried to slit the bushing to be able to get it out of there, and they got a little bit deep into the rod. If that was up here on one of the sides where it was more open here, I would be concerned about that. But since that's on the downside here where it joins onto the rod, its beam of the rod itself, I don't think that will ever bother anything. In fact, you'll see later when we roll these bushings in, it will actually push the bushing into that little bit of a groove there and probably help hold the bushing in a little bit tighter. A little chamfering tool here. I'm going to work that just by hand there a little, make sure there's no burrs on that edge where I'm going to start pressing in. And you can see one side is real sharp, the other side has a little more of a bevel. We want to make sure we press those in from the beveled side. They'll go in much easier for us. This is a split bushing. I'm going to put the split to one side. There, our first bushing is in. But you can see it didn't quite go all the way in. The bushing is a little bit narrower than the rod itself. I have a nice bushing here that'll sit on the edge there and just barely bump that in just a teeny tiny bit more. And there we have it. Bushing is much more centered. Next step in doing these is to roll them in or swedge them into the connecting rods so they stay tight. A lot of shops overlook this step or skip this step or just don't even know it needs to be done. That bushing, unless I roll that in there and swedge it tight into the rod, will eventually come out. When they're new, they leave a lot of metal in there. My pin is nowhere close to even being able to go in. I put it on the gauge here. I have, well, it goes to 7 8/1000ths. I've got 8+ thousandths to take out of that. But what we do with a lot of that is swedge that bushing into the rod on the same machine here that we're going to finish it on. So I'll take out the big end mandrel and I put in a swedging mandrel. And what this mounts to is there's one burnishing tool here that when I expand this and run the rod across that, it will actually expand that bushing into all the little imperfections that are inside the bait or the small end of that rod. And I guess I should have shown that better, but they are purposely left quite rough on the inside. They do not have a highly polished machined surface. And the intent is to swedge that bushing into that roughness so it will stay in place. And in doing this, we need to turn the pressure up quite high on the machine so it'll force that bushing out. Make sure the oil is aimed so we have plenty of coolant running on there, because this will get warm doing this. And every time I make a pass, I'm going to turn this up 1/1000th of an inch. I don't know if you can see that or not, but it is swedging that bushing out into the eye of the rod. I've still got quite a bit to go there. Let's try another 5/1000 or maybe 6/1000. But you can see as it swells that bushing out, it's also swedging the bushing longer. It's starting to stick out here on each side just a little bit. So let's go 6 more and see what happens. At this point, that has gotten hot enough that I can't keep my fingers on there anymore. And you can see there's quite a bit of this bushing hanging out on either side here. And that's what this little cutter tool back here is for. I'll go ahead and go back on here, go up against that. And that will trim that bushing flush with the side of the rod. Now we're perfectly flush now. Back to this little chamfering tool. This can actually be mounted in the machine if you have some pretty heavy duty work to do. But I generally just take it by hand and put a nice chamfer on both sides of the bushing. And I'll probably do this again by the time we're finished, but that allows the bushing to, or the pin to go in much easier. Okay, the next step on these rods, see that hole in the top? That's where that pin oils from. Putting a new bushing in, there's no hole in there anymore. We have to go back and drill that hole out. So I've gone and got a drill bit that matches the existing hole, and just simple by hand. Well, it's simple by hand if your bit is sharp. Whoa! Oops! No one was supposed to see that. Okay, there we got a hole in that one. Now we're changing over to an actual honing mandrel that does have the stone in here. And with the trimming sleeve, basically get the mandrel wet with the honing oil and then run it with no further lubrication. And this will, as I work this back and forth, it'll work up a slurry on here that will help to wear the shoes, and the stone will break down. It'll make my mandrel true. Okay, so with that, we'll turn the oil back on and start honing the rods just a little. There, about a 0.5 left. So I'm going to stop at that point with the coarse stone, and we'll come back later with a finished stone. See that rod, I've got 5/10,000ths to go. Our finished size was 2 to 8/10,000ths clearance. So let's see where we can get to with that. Turn the coolant on. I would just as soon put this in about the middle of spec. about 5/10,000ths clearance would be the middle of the step. Might be just a little shy of our 5/10,000ths. And with that, I do have much better feel on that pin, and it will slide through under its own weight. I think I'm going to stop right there. Okay, I don't know how well this will show on camera, but this is now our finished bushing. It has been pressed into the rod, swedged into the rod, rough honed, finished honed to 1/2 thousandths of an inch clearance. We have drilled the oil hole in it so it will oil, trimmed the sides flush, chamfered the edges, and with that, you can't force the pin in, but if you get it up there and line up just right, it slides in ever so nice. No more of this, I can't move that pin around, slop it around in there like it was when we started. And not much more you could ask for as far as the fit of a pin bushing. But there is one last thing. We have to make sure that the wrist pin is in perfect alignment with the crank pin end. So I'm going to rinse these rods off just a little bit, and we'll come back on the straightening fixture, and I'll show you how we check them for alignment and align them if they are not parallel with each other. We have this special fixture here. It centers up on the big end of the rod, and then with this gauge here and a feeler gauge up against this flat surface, we come down here and slipping the feeler gauge in there, I can tell if that rod is straight or twisted. And this one here, feeler gauge is tight on this side, slides right in there. So that tells me I have a little bit of twist in that rod. Checking this direction, I can see if it is bent in this direction, and I'm tight on that side and loose here. And you always want to take the bend out of the rod first before you attempt to take out the twist. So to do that, I clamp the rod in my rod vise here, and I get out the bar and I literally bend that rod back the way it needs to be. So I'll start out giving it a little tweak there, and this is purely by feel. It just takes a little experience of doing this to figure out what works. See, I'm still tight here, loose on that side, so I gotta give it a little bit more. Oh, look at that. That has a nice feel to it. So we've got it corrected in that direction. Now we'll try a twist, and look there. In straightening the bend, I also took the twist out. Everything feels good that way. Now, if you're curious if my fixture is correct, we flip the rod around 180 degrees and we check again. I feel good in the bend direction. I feel good in the twist direction. So that rod is done. Uh-oh, we've got some twist there. Bend, we feel pretty good. There, that's feeling better. So there we have it. We are ready to assemble this engine. We have all the machine work done that's going to be done. Customer asked that I put this back together as far as what it was when it came in, plus the pistons and rods. There's going to be a little bit of concern here on our piston height coming up out of the top of the block. We'll put one rod and piston in without the rings on, just to see where things come to. Putting the camshaft back in this engine. When we took it apart, we did scribe little numbers on the back side of all the lifters here so that we can make sure we put them back in the same position again.
And you're putting driven assembly lube on it?
Yeah, using our driven engine assembly grease. We've had real good luck with the driven brand break-in oils on flat tappet cam type engines. Put a coating on that on all the lobes and the cam journals. Interesting note, there are no cam bearings on this engine. The camshaft rides right in the cast iron block. A lot of industrial motors are that way.
New and old.
New and old, yes. Even your 5.9 Cummins motor, they only have a cam bearing in the front. There's a few of them that have a cam bearing in the back, but for the most part, they run the cam right in the cast iron block. Now then, here on the camshaft thrust plate, I am going to just put a little straight oil on that behind the plate.
So he said put it back like it was when it came in. Should we wedge that driver in the bottom of one of the sleeves?
Yeah, leave it in there for me.
I cannot wrap my mind around how he got that thing in under the crank.
And we're certainly not making fun of our customer here, because I'm all for customers doing as much as they can themselves. You know, I'm a do-it-yourselfer myself when it comes to different things that are outside of my expertise here, and it gives you great pleasure to be able to do some hands-on things. We've done all kinds of remodeling on houses and building this shop building here, and I certainly wouldn't call ourselves carpenters by no means at all. But we also know where our limitations are and know when to stop and get some help.
One example I can think of is when I lived in Boulder and we were trying to put that ice maker in the fridge or something.
Right.
And all of a sudden we had water spraying everywhere, and we managed to get the pipe patched up and called a plumber because figured out we were in over
our head, and in a condo situation where what we were doing there really could cause some problems for other people.
Yeah. Convenient that we were in the unit that had the water shut off for the whole building, though.
Yeah, that was the convenient part of that. I've got the crank installed in the engine. We are ready to put a piston and rod in because we need to check piston protrusion on this because of having surfaced as much off the deck as has been done on this engine. Put a little lubrication on my wrist pin bore. They're a little bit inside the connecting rod.
And that's not ketchup.
That's not ketchup. That's Michigan. Showing my age here. That's Cleveite bearing guard. Back in the day.
How long has it been since it was Michigan bearing?
Probably 20 years.
Probably longer, I bet.
I'll put it in without the rings just for testing purposes. Okay, let's turn this around and see how far that piston comes out of there. Oh, we got all kinds of
It's
clearance.
not even above, is it?
It's not even above, which is what I anticipated the case would be. We're about 22 in the hole, 23 maybe.
Plenty.
Yeah, I had been perfectly happy even if this piston had come slightly above the deck, because we have thick enough head gasket that it never would have been an issue. Okay, well, I think we're ready to put the pistons in now. I've got the bearings in the rods, I've got the rings on the pistons, so I'm going to put a little lube in each one of the bearings. Get everything just right, it goes, but you definitely don't want to force it. Line the cap with the rod. Okay, there's 45 pounds. I do have just a little bit of side play. It still turns like it should.
Mains are torqued.
Mains are torqued. We torqued those earlier. Put the rear seal in, put the little rubber strips along the side of the main cap to seal it. Drove the little, basically a little nail down the side that expands it tight in there. Well, we have about 30 thousandths in the hole.
Yep.
Real close. That one's maybe 27. 28. That was a little higher.
25.
Yeah.
And you pretty much know the variation there has to be in the rods or the crank or the piston, because it wasn't like it was getting taller one way or the other. It's
No.
30, 25, 28, 27.
When you initially surfaced the deck of this block, I don't remember which end it was, but it looked like you were cutting at an angle.
Yeah, it was about, so when I initially surfaced the block, I don't remember which direction was high, but from front to back, there was definitely about 5 thousandths. And from this side to this side was over 10 thousandths.
Yeah.
So it was all sorts of, and then warped kind of funny on top of it.
But what little difference we have now is because of difference in rod length, difference in stroke length on the crank, or the piston itself, from the top of the piston to the pin. But I'm real pleased with that. That's very close. There's machining tolerances, and sometimes they stack up in your favor and sometimes they stack up against you. And this time I'd say they've definitely stacked in our favor, because I'm real pleased with it.
Yep.